Alright, hey there again, kiddos. This video is going to be writing equations for linear functions, which there's really not a lot new here, except we're going to make sure we write the equation and then use it to answer a few questions. So this video should be relatively short because there's not a lot that's new. I picked some of the harder questions, and those are the ones I want to focus on to make sure that we are getting this and understanding it. So your first one, Jessica's going to go to the state fair. The cost of admission, because she didn't get her free ticket from school, is $14, and the cost for each food coupon is 50 cents. Part A, write let statements and then an equation to represent Jessica's total cost at the fair. Well, let's go through what we know. Cost her $14 to get in. How many times does she pay that? She pays it once. She's going to pay the cost of admission just to walk in, so there's no variable associated. But each food coupon is 50 cents. So we're going to let C equal food coupons. That's our let statement. If you really want it to be a let statement, then you say let C equal food coupon. So now we're going to write an equation. Well, we know that she has to pay, and then T, we're going to have two variables, is going to be her total cost. I apologize. So we have two variables, C for food coupons, T for total cost. So her total cost is going to be the cost of admission plus 50 cents for every coupon she buys. So there is the equation. $14 to get in, 50 cents for each food coupon. So part B says if she buys 40 food coupons, how much did she spend? Well, let's use our equation. $14 plus 50 cents for 40 coupons. Well, it's just a matter of evaluating from here. 50 cents times 40 is going to be 20 because that's half of 40. And so 14 plus 20 is 34. So if she buys 40 food coupons, she's going to spend $34 at the fair. This is provided Jessica does not go to the Midway and play any of the games. All she does is go in and buy food. Which we all know the Midway is the most fun part of the fair. So why she would skip that is beyond me, but we're not going to factor that in because that makes this a more difficult equation to solve. So, part C, if Jessica spends $26.50, how many food coupons did she buy? Now we're working backwards. This is our original equation. And we know that her total was $26.50. That's an equal sign, not a plus sign. So I want to solve this for C. Step 1, subtract 14 from both sides. Which is $12.50. And each coupon was 50 cents, so I'm going to divide by 50 cents to figure out how many coupons she bought. And she bought 25 coupons. So that in this case, we just work backwards. Part D, same kind of question. She has $31 to spend at the fair. How many food coupons can she buy? So again, we start with the same equation. But this time my total is $31. And I solve it the same way. I'm going to subtract 14. I'm not going to show it this time though because y'all understand what I'm doing. So I have 17 equals 0.50C. And then I'm going to divide by 50 cents. And I'm going to get that she can buy 34 coupons if she has $31 to spend. So let's do a couple more. The second one, I'm going to move this because it's in the way. A candy company sells boxes of chocolate-covered almonds. An empty box weighs 5.7 ounces. Each piece of candy weighs 1.6 ounces. Write an equation to represent the total weight in ounces W of a box of chocolate-covered almonds in terms of A, the number of candies in the box. In this case, they have given you the variables. W is the total weight of the box. A is the number of chocolate-covered almonds in the box. So, the total weight of the box is the weight of the box by itself, which is 5.7 ounces, plus the weight of each candy. Well, each candy is 1.6 ounces each, And we don't know how many there are, so there is the equation. You are asked to do nothing else with this. It just says write an equation in terms of A. That means A needs to be over here on the other side from the W. So we're done. That's all there is to that question. Now this last one, it's not tough. It's not really difficult. It's just a little tricky. So that's why I put it in here. So, Jenna's pre-AP algebra grade after the first 6 weeks was 70%. For the record, we are not at the end of the first 6 weeks, and this is not really Jenna's grade. It just happened to work well for the problem. So, Jenna, don't panic. Okay, Jenna wanted to improve her grade, so she began to study at least 1 extra hour each day. As Jenna tracked the number of extra hours that she studied, she realized her average went up by 2% for every 5 extra hours of study time. Part A says write an equation that represents Jenna's total average as a function of H hours. What that means is in terms of H. So we are going to have to first write an equation. We're going to let T be our total average. And we're going to let H be number of hours studied. Or number of extra hours. Okay? So here's what we know. Right now she has a 70. But her average goes up 2% for every 5 hours of study time. I can write this as a ratio. I am not going to write it as 2%. I'm just going to leave it as 2 because it goes up 2 percentage points. So she's going to go up 2 points for every 5 hours of study time. And I can write that as a ratio as 2% for every 5 hours. All right, that's this represented. So, and it's going to increase by that much. So right now, Jenna's average is a 70. But it increases 2% for every 5 hours that she studies. And so that's going to be our equation. The 2 over 5 came from the 2% for every 5 hours. I just wrote it as a ratio. And if I multiply that times the number of hours that she studies, that will give me the number of points her average is going to increase by. And so there is the equation for her thing. So next, part B says, what will Jenna's average be after 30 hours of extra study time? Well, let's find out. That means we want H to be 30. So then we just have to do the mathematics that are, just do the operations. We're going to multiply 2/5 times 30 first. What's another way to say 2/5? I believe it's 0.4. I don't believe, I know it's 0.4. 2/5 is the same as 0.4. So we're going to do 0.4 times 30. Another way to do this problem is to do 2 times 30 and then divide by 5. You'll get the same answer. And so what you get is 70 plus 12. So for 30 extra hours of study time, her average is going to increase by 12 points. And so her average after 30 extra hours is going to be an 82%. So her new average is now an 82. So if her average is now an 86, we want to find out how many extra hours she studied. So, same equation, except now T is 86. And we want to figure out what H is. Let's start this like we have started all of our problems that have a fraction, and we are going to multiply by 5 so that our denominator goes away. Well, 86 times 5 is 430. So this comes out to be 430 equals, now I have to do 70 times 5 also, which is 350 plus, now this 5 cancels, so you're left with 2H. So I have to do 5 times 70 because it is not part of the numerator, it is separate. And then when I do the fraction times 5, the 5's cancel each other out. So here's my equation, I'm going to get H. So I'm going to subtract 350. So 430 minus 350 is 80. Equals 2H, and then when I divide by 2, I get that she studied 40 extra hours in order to increase her average to an 86. So there's the answer to that question. Okay, so this is writing equations for linear functions. Like I said, there's not a whole lot that's new. You're just going to write an equation and then evaluate it. Make sure when you do these tomorrow, you read each question very carefully. Ask questions if you have them. We will practice this some more tomorrow. Okay? Have a good evening.